All right. Well, I'm Connor Arthur, and today we will be discussing medical practice in the Western world from 1800 to 1900. And right here we have a picture of a 17th century public dissection. So, medical practice before the 19th century was really quite an informal affair. Most people did not go to medical doctors for treatment. For centuries, however, medical theory had basically been focused on this idea of four humors. You had your blood, you had phlegm, you know, the green stuff comes out of your nose, black bile and yellow bile, which don't really correspond to an internal substance. It was just kind of, Galen made it up. Galen was this Roman doctor. And he wrote about this, and his medical books survived throughout the centuries, and that's how Western doctors basically were like, you've got an imbalance of your humors, let me bleed you. Yeah, so literally bloodletting was one of the main forms of treatment. I don't understand why they didn't think of trying to get the other fluids out of everybody else, but whatever, you know, it doesn't really make much sense anyway, not looking back, you know. And so the doctors were not doctors, they were barber surgeons. Yeah. And that's exactly what it sounds like. The person cutting your hair would also cut you and bleed you. Nasty thing. But starting in the 17th century, the earliest stages of modern medicine were starting to be uncovered in the universities of Europe, like in this public dissection I showed you right here. Yeah. That is the 17th century scene. So the 1600s. So dissections were actually also intended partly as entertainment. Well, you know, it looks kind of interesting, you know, especially, you know, people back then, you know, wondering what's inside of them, and well, here you have a good chance to peek inside.
Was this done primarily for the entertainment of the masses, or medical, or?
So most of them were performed in universities for the students. Okay. But some doctors said, anybody who wants to come pay a little bit of money and you can watch me pull a dead guy apart. Yeah. And I can, you know, and they would guess at what the things inside the person did. Usually they were horribly wrong. Yeah. But, you know, they had at least some idea that the digestive tract is where your food goes, and, you know, your heart is what pumps your blood and all of these things. So this guy named Andreas Vesalius wrote a book, a hugely influential book, sort of the Gray's Anatomy of its day, called De Humani Corporis Fabrica, or On the Composition of the Human Body, which was the first highly detailed and medically accurate atlas of the human body. Dr. William Harvey, he was an English doctor, was the first to accurately depict blood flow in humans. And in the 1670s, a Dutch guy named Antony van Leeuwenhoek, at least that's how I think that's pronounced, started experimenting with microscopes and discovered these things called animalcules. Does anybody have a guess as to what those might be?
Blood?
Bacteria.
Oh, bacteria.
Yes, microorganisms. In 1696, the first public medical dispensary opened in London, so the first pharmacy basically. In 1722, Guy's Hospital in London became the prototype of the modern hospital. And in the 18th century, the largest medical school was Edinburgh Medical School in Scotland, which produced 11,000 medical graduates in the 18th century. So if you were being treated by a doctor in Britain and maybe the continent, there's a very high chance that they had attended that school, because they were just pumping out medical graduates to meet the demand for doctors. But you see, not all of the doctors were necessarily called doctor. Most of them called themselves physicians because they were not doctors of medicine, because doctor is actually just a degree that you have in order to be able to teach at a university. So all doctors of medicine theoretically have the ability to teach medicine at a university. So these are bloodletting tools of a barber surgeon. You know, not necessarily sure what you do. Oh, I think those are, that's like something that cuts you right there. I don't know. But usually they just did it with a knife. So whichever barber surgeon owned these must have been rather well off.
Wow.
Yeah. So then here is that William Harvey fellow I told you about earlier, the first to describe the proper mechanisms of blood flow. And here are some of his illustrations. You know, you could, you know, he's demonstrating here that if you put your finger on that spot, you can feel somebody's pulse. And this is Andreas Vesalius. He was doctor to Charles V, Holy Roman Emperor, and he produced the De Humani Corporis Fabrica. And here is a skeleton that he had reassembled for display purposes. It is the body of a German peasant named Jacob Carr, who must have involuntarily donated his body to Dr. Vesalius.
Left his hands and feet behind.
Yeah, you can see that the skeleton is not particularly well preserved.
Yeah.
So he must have, either pieces have gotten lost over the centuries. This is about a 500-year-old skeleton here. Or he died in a particularly violent accident. And then here are some drawings from Vesalius's book here, depicting the skeleton. As you can see, very detailed, very well accurate. And then here are his illustrations of the muscular system,
Wow.
or a person without his skin. Yeah,
Pretty good.
yeah, very, very detailed. Before Gray's Anatomy had come out, this was the book to have if you were a medical doctor. And the renal system, of which I believe at that point they were just beginning to understand that its purpose was filtering the body of toxic waste. The brain, the underside of the brain, which they had really no idea what the brain really did. In fact, there was still somewhat of a belief that the brain was like a superfluous organ, because the ancient Egyptians had believed that the brain had basically no purpose at all, so they stuck a hook in your nose, jerk it around, and pour the scrambled brains out your nose. Very obviously, medieval Europeans or early modern Europeans weren't doing that, but they had some description of it by the Romans, I believe. And here is the frontispiece of De Humani Corporis Fabrica, which shows a dissection scene in progress. And as you can see, about 100 people crowded around here watching the dissection.
So all those germs.
Yes, yeah, they didn't know anything about germ theory, but we will be talking a great deal about germ theory because the 19th century is when it finally caught on.
Good.
And this is Mr. Leeuwenhoek, you know, handsome fellow. Long hair was in fashion in the late 17th century. And here is his microscope, which doesn't look anything like a modern microscope, you see. Because for the lens, they just had this little tiny piece of glass here. And the reason why it looks like this is because they didn't have a way of artificially lighting up the specimen. So they had to face it towards a light in order to get enough light through the lens so you could see what you were looking at. And I suppose whatever specimen you were looking at would be resting on the head of that pin there. Yeah, I'm not really quite sure how you would use this yourself, but that's sort of my hypothesis anyway. It was a very advanced instrument for its time. They were only just beginning to understand optics in any advanced way, because this is at the same time that Sir Isaac Newton was making his discoveries about optics. And here we have another dissection scene, which is the anatomy lesson of Dr. Nicholas Tulp by Rembrandt. So you see, they were a very popular subject of painting in the late 17th century. And I think this is our last our context picture here. The Visceral Lecture of John Bannister from 1580. So he's got a skeleton right here, and he's pointing out the skeletal system of the person he's dissecting while the students watch. So, and in fact, one of the most influential public, just for anybody to come and watch, dissections was performed in Prague by Dr. Jan Jasenius in 1600. It was very popular mass entertainment back then. And this is the Guy's Hospital in London, built in the neoclassical style, as was the style at the time. And this is one of the very first hospitals where, you know, you would just be expected to go if you were sick. Obviously, not a very good idea, really, because, you know, going to a house full of sick people with no sanitation when you're already sick is probably not the best bet, but they were really making an effort.
Hi, question. Do you allow pictures of your lecture?
Oh, yeah. Yeah, you can take whatever
Okay,
photographs
okay.
and videos you like.
Right, thank you.
Anyway, so our first major innovator of 19th century medicine is this fellow, Dr. René Laennec, the inventor of the stethoscope. So he was born in 1781 in a town called Quimper, France, and his mother died of tuberculosis when he was a youngster, and he was raised by his great uncle, which probably motivated him to become a doctor. You know, many of these doctors had a tragedy relating to disease in their immediate family, which is what motivated them to pursue medicine. So he went to Nantes, where he went to go live with his uncle, Guillaume Francois Laennec, who worked in the Faculty of Medicine at the university there, and he was a gifted student. He was quite bright. And in 1799, when he was a medical student, and he briefly took a break from his medical studies to study literature. And the story goes, when he invented the stethoscope, he was attempting to treat a female patient, and in order to better listen to her heartbeat, he fashioned a piece of paper into a tube so he could listen to her heartbeat better. He is reputed as a very pious man and a devout Catholic, and he was very popular due to his generosity with the poor. As you must understand, in the late 18th, early 19th century, France, especially Brittany, was a very poor region. So generosity to the poor would have been very well appreciated at that time. You know, and a doctor, you know, doctors make a lot of money even back then. He was very well off.
He died at 45.
Yes, he died in 1826 in Ploire, Brittany, of tuberculosis.
Oh,
Yes, tuberculosis claimed many lives,
it ran in his
especially
family.
doctors. Yeah, so brought into the world with a tragedy from tuberculosis and taken out of it with tuberculosis. But here is his patent drawing of the stethoscope, or not the kind, you know, like doctors have now with the two things that go in your ear and the rubber tube. That was invented after 1900. And instead, for the 19th century, stethoscopes were a wooden tube. And you would, one of the other reasons why he invented the stethoscope is because he considered it very embarrassing to have to place his ear up against the chest of a female patient. So that also helped. Anyway, our next doctor, you might have heard of him, none other than Henry Gray. Yes, that Henry Gray of Gray's Anatomy. So Henry Gray, the Fellow of the Royal Society, was an English anatomist and surgeon who lived from 1827 to 1861, another early death, or early by our standards. Back then it was not totally abnormal to only live that long. He was born in Belgravia, London, and entered as a student at St. George's Hospital, which is not in Belgravia today, but is in Tooting, but back then it hadn't yet moved. And he was known as a thorough dissector while he was a medical student there. You know, he paid great attention to the dissections and participated in many himself, both as an assistant and a lead dissector. And it would be the knowledge that he gained through these dissections that would prove invaluable to the research in his book. He won 2 prizes, the Triennial Prize of the Royal Society of Surgeons for an essay about the nerves of the eye compared to those of animals. And he was awarded the Astley Cooper Prize of 300 guineas, which was a considerable sum of money back then. He probably could have quit working if he wanted to, but you know, he was too dedicated to his work, for a dissertation on the spleen. And he worked on anatomy with another doctor named Henry Van Dyke Carter, who provided the illustrations for the book while he wrote the text. They had access to the bodies for the studies due to this thing called the Anatomy Act of 1832, which allowed doctors to use unclaimed bodies from workhouses and hospital mortuaries. So, kind of nasty, but a great deal of medical knowledge was gained from this. And also the law was passed in reaction to murders and grave robberies conducted by medical students to get access to bodies. So they finally decided, well, you know, maybe it would just be better if we kind of just let them have, you know, corpses that nobody wants, you know, instead of them having to get a little bit criminal. He died of smallpox in 1861 after caring for his 10-year-old nephew who, unlike him, managed to survive the smallpox. And in fact, he had a very severe form of smallpox where you couldn't see individual pockmarks on him. It was just a sheet of redness on his body. Very nasty. But Gray's Anatomy survived him by almost 200 years. And it's currently in its 42nd edition, which was published in 2020. So definitely not a bad legacy, not a bad track record for Mr. Gray, Dr. Gray. And here is his grave, which is in Highgate Cemetery in London. So yes, very, very good doctor here. And we have some illustrations from his book. Illustration of the bones of the hand. Very, very highly detailed. I believe that the original illustrations are still in the current editions of the book.
Oh,
So they've really stood the test of time. You know, because human beings, they don't really change, you know, so if you get it right one time, you know. And here are the bones of the skull. You know, lots of very tiny bones in the front of your face. They're actually all independent bones. That just locked together. And next doctor we have to discuss here is Robert Koch, who was one of the first to be a serious studier of germ theory. So Heinrich Hermann Robert Koch was born in Clausthal, the Kingdom of Hanover, in 1843 to Hermann and Mathilde Koch. And his father was a mining engineer, and he was one of 13 children. So a very large family he was born to. He taught himself how to read and write before going to school in 1848, so he was already far ahead of his classmates. I don't mean to brag, but I've been able to read since I was 3 years old.
wow.
So I guess I'm somewhat like him.
But
He
you're
went.
not a doctor.
I'm not a doctor. Well, not a doctor yet, but not a medical doctor anyway. But he went to the University of Göttingen where he studied mathematics, but he changed to medicine when he was told by a colleague about how great the medical profession was and how doctors, you know, are advancing science so far and making money too. So he became well known for his research with anthrax, and he discovered that the disease was caused by microbes. So one of the very first doctors to prove that disease, or at least some diseases, are in fact caused by those animalcules of Leeuwenhoek. So he proved that tuberculosis was caused by bacteria, however, he attempted to create a cure using chemicals derived from tuberculosis bacteria cultures, but discovered that injecting people with tuberculosis bacteria juice just causes their tissues to necrotize, which killed the animals that he tested it on. But he did cure it because the bacteria starved. So, but unfortunately, the cure that kills the patient is not necessarily a very good cure.
Yeah.
Never tested in humans, hopefully. The Petri dish was invented in his laboratory by his assistant, Julius Richard Petri. And he was sent to Egypt in 1883 to study an ongoing cholera outbreak. But the outbreak pretty much got over very soon after they had first arrived in Egypt, causing them to go to India, where they discovered that the source of cholera is bacteria in the Ganges River, which to this day is a stinking cesspit.
Yeah.
So he determined that the bacteria in both outbreaks were the same species of bacteria called, I believe they're called Vibrio cholerae. He died in 1910 in Baden-Baden, Grand Duchy of Baden. So here is his assistant, Julius Richard Petri. Sorry, this is his only photograph, so it's a little blurry, I'm sorry. And the Petri dish, of which I'm sure you've heard of. Very important for isolating the bacteria cultures, which was very essential to the research that they conducted. So Koch also developed these three, he developed three postulates initially. There was a fourth added on later by somebody who wasn't him. Anyway, so the first is that the organism must be present in every case of the disease, but not in healthy individuals. So when they're talking about the organism, they mean bacteria here. So the Vibrio cholerae were only found in people who had cholera. You know, shocking. The second is that the organism must be isolated from a diseased individual and grown in a pure culture, so in the petri dish. And number three is that the pure culture must cause the same disease when inoculated or injected into a healthy, susceptible individual. So, yes, mostly this was done on animals, but occasionally there were human volunteers. Who would volunteer to be injected with cholera? Well, right, you wouldn't want to. Anyway, an American botanist named Irwin Frank Smith, however, proposed a fourth postulate in 1905, which is the same pathogen must be isolated from the experimentally infected individuals. But that's not a Koch postulate, and it was invented in 1905, so not the 19th century. But anyway, and here are those cholera bacteria under a microscope. You know, they look like every other bacteria, but, well, except if they're the ones that have a little tail, whatever. They're all very weird, these bacteria. But anyway, and here is Koch in Egypt. I believe that is him right there. You know. So our next doctor was one who followed in his footsteps, or basically researched at about the same time as him anyway. Was Dr. Theodor Schwann, born 1810 in Neuss, died 1882 in Cologne, who was a German physician and physiologist who proposed the theory that all animals are made up of cells. All of us. Not just the little animalcules, bacteria, but you and me made up of millions of little tiny cells. Which previously microorganisms had been classified as a sui generis, or a class of their own type of life form, or not having any relation at all with us macro animals. So he also discovered a type of brain cell called the Schwann cell. He discovered the digestive enzyme called pepsin, which helps us break down our food. He discovered that fermentation was caused by yeast bacteria. Now, this is a discovery that was also achieved around the same time by Louis Pasteur, who we're going to talk about in a second. He studied muscular contraction and was elected as an international member by the American Philosophical Society, which used to admit scientists due to science being initially considered a variant of philosophy, or natural philosophy. So, what about practical medical practice? So, not just this theoretical research. So this guy, his name is Ignác Semmelweis, and he was a Hungarian doctor from Eisenstadt, or Kies-Marton, which is now in Austria, who worked at a maternity ward in Vienna's General Hospital. So Dr. Semmelweis basically had noticed that doctors would immediately go from performing dissections on corpses in the mortuary to delivering babies. Very nasty, very nasty. So he said, well, are you going to go and deliver babies with those hands? You know, and they're covered in nasty, all kinds of body juices. And basically the doctors would be like, you know, maybe that's a good idea. Maybe I should wash my hands. So he would have them wash their hands in a solution of diluted lime. Well, you see, anything to kill the bacteria. He actually didn't know about germ theory. He had basically suspected that there was some kind of disease-causing agent getting onto these people's hands, and washing it off would probably be good for delivering babies, right?
Diluted lime we use today, it's soap.
Yeah, lime is in soap. So Dr. Semmelweis told the doctors to wash their hands, and his methods were questioned by the doctors of the day. They felt insulted that Dr. Semmelweis was insinuating that they had dirty hands. Are you calling my hands dirty? You, sir, are a lunatic. But anyway, despite objective proof of this hand washing reducing mortality by almost 40%. So basically, the other doctors tried to deflect blame onto the women by saying that their regions were not clean, so they would wash those areas. But obviously that didn't really help as much as washing their hands, right? Because people can have an ego. It's kind of bad. But anyway, in 1865 he was committed to a mental institution due to lashing out at his critics, where he died of infection. So not a good end to Dr. Semmelweis here, but history proved him right, and now everybody washes their hands, for which I am very grateful. Anyway, for a more successful and less tragic story, we have the story of Dr. John Snow, or the founder of epidemiology. So Dr. Snow, who lived from 1813 to 1856, was a York-born English doctor who lived in London during an outbreak of cholera. One of the major killers of the 19th century was cholera from contaminated water, which happened in 1854. And he suspected that the contaminated water was the source of the outbreak, which he was correct. Because you see, London got their drinking water from the Thames River, which, as you might know, is like the Ganges. It's not very clean, especially the further downstream you go. So he told the local council to remove the handle from the water pump and tell everybody to go further upstream to get their water, which had the mysterious effect of reducing the cholera outbreak. Right? Anyway, so he traced the diseases to areas with water pumps downstream of the Thames, specifically the Broad Street pump, which was even worse due to being built next to a cesspit, which was leaking fecal matter into the water supply. So, drinking poop water, not a great idea. But anyway.
Which as bad as it sounds, is also where the primary water for New York, Manhattan was when they first set it up.
Oh yeah, by the way, most every city in the world at this point was getting their water from a dirty river. But basically he figured out, well, hold on everybody, if you drink clean water, suddenly you won't get cholera. But anyway, he was very famous for defeating the Broad Street cholera outbreak, but he was also an innovator in anesthesia. And he didn't invent, but he greatly advanced the practice of using ether and chloroform to put people to sleep before cutting them open. So, very nice. So here is a replica of that water pump, not the original. The original is lost to history, with the handle conspicuously removed, just like he requested to the council. And there's a pub on Broad Street also named after him there, the John Snow Public House. So he's very fondly remembered in that part of London. And here we have some satirical cartoons from Punch talking about the dirty state of the Thames. So Father Thames introducing his offspring to the fair city of London. And we have diphtheria, scrofula, and cholera right there being presented to a personification of London. And here we have Michael Faraday, who was a very famous early scientist, who was a public lecturer just like myself, presenting his card to Father Thames. And however, they wanted a long-term solution to all this poop water. So what they decided was that they were going to build a pumping station to filter the water and treat it in order to provide drinking water to London. And this, you would never guess if I told you if I didn't tell you what this was. Like if you didn't know that this was a pumping station, what would you think that this building was?
Movie theater.
Movie theater, church, all good answers. But no, that's just good taste in action. You see, even in Victorian England, even their poop water pumping stations were majestic. I think that this philosophy of public design ought to come back. Anyway, so now we reach Louis Pasteur, Le Grand Docteur. He was born in 1822 in Dole, Burgundy, Bourbon Restoration, France. he was the son of a tanner, Jean Joseph, and his mother, Jean Etienne. And they both had Jean as their name. That's sort of interesting. But he was dyslexic, so people probably wouldn't guess that about Louis Pasteur, being so smart, that he had a hard time reading. But he managed to do well in school despite this with effort, and even had an interest in painting. So there's an alternate history, Louis Pasteur, who doesn't become a doctor or scientist at all and becomes a famous painter instead. But it didn't work out for him, so he chose to be a scientist instead. And he conducted research on multiple topics such as physics and medicine. We're going to talk about his medicinal achievements here. And is most famous for linking bacteria to disease once and for all. Basically confirming the theories of Robert Koch and Theodor Schwann that basically most diseases are caused by little tiny things getting inside of you and screwing you up. So he discovered fermentation was more effective in the absence of air. So initially most of his scientific work was actually helping out people at wineries, because as you might know, Burgundy is a very famous region for its wine. And he discovered pasteurization to kill microbes in wine to prevent it from going sour. And then it was also applied to milk. So virtually all the milk that you drink ever has been pasteurized to prevent bacteria from, getting into it and making you sick. So he discovered the diseases of silkworms, which France back then had a huge silk manufacturing industry, biggest in the Western world. Still has a fairly substantial silk manufacturing industry these days. Was caused by bacteria infecting the silkworms. He invented the rabies and anthrax vaccines, which have saved countless lives. And he conducted experiments to prove that yeast did not spontaneously appear in grape juice, which was actually the conventional wisdom at the time, that if you just have grape juice, it's inevitable that yeast is going to just kind of show up in it. But he proved that that's not true by sticking a needle into grapes, extracting the juice, and putting it into an airtight container, and proving that the grape juice did not turn into wine. And he proved instead that the yeast comes from the grape skins. And he died in 1895 of a stroke that he suffered the year before he finally succumbed to the aftermath. And he was given a state funeral and buried at Notre Dame. So a fitting end to one of France's brightest sons. Admired him greatly. So here is Louis Pasteur working in his laboratory with bacteria. I have no idea what he's really doing there. Probably, I imagine that that's some kind of vacuum chamber for pumping the air out of it and putting something of some kind in there. He's probably performing a fermentation experiment, if I had to guess. And here is his birth house in Dole, which is this central building right here. Rather unassuming, but his family was not wealthy. They were not very well off. So I believe they lived in an apartment at that building. They didn't own the whole building. And here are some of his paintings of his father and his mother, which his paintings aren't bad. I like them. So I do think he probably could have made a career out of painting if he hadn't had such a great interest in science. And also, here is Joseph Meister, or the first person in the world to be vaccinated against rabies, who he had been mauled by a dog they thought had rabies. They didn't know, but probably did. And they went to Dr. Pasteur and asked to have their son vaccinated. Now, there was a bit of risk in this because Louis Pasteur was technically not a doctor. He was a chemist, which was a different qualification, which is a different qualification. But the family decided to just ignore that and let their son get vaccinated. He lived until 1940, when France was invaded by Nazi Germany, and he killed himself. Yes. So a very sad end to Joseph Meister. There are different reasons why people believe different things about what he did, why he did that, but they believed that it was to avoid handing over, because he worked at the Pasteur Institute when he became an adult, and was privy to secret research there that he probably didn't want falling into Nazi hands. Moving on to another British doctor, we have Joseph Lister, or a pioneer of antiseptic. So Ignaz Semmelweis had finally figured out if we wash our hands, people will not die in childbirth as much. Lister basically said, well, you know, we need sanitary conditions in these operating theaters then, because if we're cutting people open, who knows what kind of germs are going to get into them, right? So he lived from 1827 to 1912, and he was born to a prosperous family of Quakers from Upton, which used to be outside of London, but has since been swallowed by London. And he was the fourth child and the second of 4 sons and 3 daughters. He was one of 7 children. And his father was a wine merchant, also named Joseph, so he was technically Joseph Lister Jr., and his mother's name was Isabella. So he went to University College London to become a doctor, and he hypothesized that microorganisms getting into the wounds caused them to be infected, which is true. He devised a contraption called the carbolic steam spray to kill germs and sterilize operating theaters, but the reason why this invention is not used today is because it is horribly irritating to the human person. Doctors couldn't hardly stand to stay in the operating theater for very long if the carbolic steam spray was being used, but it did prevent infection. So, you know, which would you rather have? You know, get some red eyes or get an infection and die. So, sounds like a good trade-off to me. But later, the carbolic steam spray mechanism was phased out after 1900 in favor of disinfecting the instruments themselves and just generally trying to keep operating theaters clean, which is what we do these days. He served as the 37th president of the Royal Society from 1895 to 1900. So he was very well honored. He was also elevated to the nobility. He became the first Baron Lister. Unfortunately, I think the Lister peerage has died out. He doesn't have any direct descendants.
And Listerine is named after
Oh
him.
yes, Listerine, the mouthwash. Initially it was a floor cleaner. Yes, Listerine used to be a floor cleaner, and then they started recommending it for oral use. But yes, they named it after Lister because he was very, very famous for going after the germs. And here is his carbolic steam spray apparatus. They have a bottle of carbolic acid here, and it gets heated up from some burning coals down there, and they would spray out steam of carbolic acid, and the operating theater would be covered in this yellow mist. Yeah, sounds nasty. It was nasty, but not nearly as nasty for us as it was for the germs. So then, what about Rudolf Virchow? And he, unlike some of these other doctors you might have heard of, he's rather obscure. I've never heard anybody talking about Rudolf Virchow, despite the important contributions to medicine that he's made. So important, in fact, that they called him the Pope of Medicine, which would turn out to be pretty ironic, as you'll learn in a second. So Rudolf Virchow was a Prussian doctor who lived from 1821 to 1902. He was born in Świdwin, province of Pomerania, which is now called Svidvin in Poland. He produced 2,000 medical writings throughout his career, an enormous corpus of work. And he introduced the concept of all cells having come from other cells. So initially, they weren't quite sure about where cells came from. They thought that they spontaneously generated. And then he observed mitosis and saw, well, generally all cells seem to come from other cells, don't you know? He extrapolated from this that cancer cells are malfunctioning normal cells, which is true. He was the first to name and describe leukemia, chordoma, ochronosis, embolisms, and thrombosis. He also coined the terms neuralgia, which I believe is a type of brain cell, agenesis, or the absence of an organ, parenchyma, osteoid, spina bifida, the Virchow-Robin space, which is a type of area in your brain where your blood vessels are surrounded by fluid, and amyloid degeneration. I'm not sure what some of those are, I can't remember. I wish I could. But that's just how many things he discovered, you know. He was opposed, however, to Darwin's theory of evolution. He called it nonsense. He thought that the early human skeletons were nothing more than deformed humans. Which, you know, is a fair criticism to make in the day. They didn't know.
Particularly if you studied spina bifida.
Oh yeah, spina bifida, yes. I have a diagram of that I'm going to show you. Now, he was a virulent supporter of Chancellor Otto von Bismarck, his bigoted Kulturkampf campaign against Catholics in Prussia, and was, you see how it's ironic they call him the Pope of Medicine, that he was bigoted against Catholics. And he was elected to the Prussian Reichstag in the 1850s as a member of Bismarck's government. On the other hand, however, he was a public critic of the Völkisch movement, or the racialist predecessor to Nazi race pseudoscience. He conducted experiments in 1885 to disprove scientific racism, and his conclusion was that there was no significant difference between one race or another in real terms, which was insanely progressive for the era. He dismissed, however, the germ theory of disease and criticized Ignaz Semmelweis. So he's one of the people who led Semmelweis to the insane asylum. So you can see Rudolf Virchow, he's got a bit of a mixed legacy. And he served as a physician to Kaiser Frederick III, who had laryngeal cancer because he was an avid smoker. Sadly, however, Dr. Virchow's treatments were not enough for the young monarch. Dr. Virchow's treatments basically can be boiled down to scraping the inside of the young Kaiser's throat and telling him to go to, I believe he went to a spa town and gargled spa water as an attempted cure, which didn't work. And Kaiser Frederick III dropped dead in 99 days into his reign. So a lot of people don't remember him. People think that Wilhelm I was followed by Wilhelm II, but Frederick III actually was this brief, they call it the Year of the Three Emperors, 1888. The death of Frederick III is viewed as a turning point in German history because they believe that perhaps Germany would have had a less aggressive foreign policy if Frederick III had been allowed to continue reigning. So this is a young Dr. Virchow. This is a diagram of spina bifida, which is basically this horrible deformity that affects about, I believe it was about, I can't remember what the statistics are, but it's not super common, but it's not super rare either. Where basically an infant will have this sort of problem here with their spinal cord. Usually it's not so pronounced. In fact, usually it's called spina bifida occulta, or hidden. But usually doctors have to do a corrective surgery to fix it. Very, very sad deformity. This is Frederick III, the Emperor of Germany, who died to throat cancer. It was very sad that he couldn't be saved. And here is him and his son, Kaiser Wilhelm II, at Balmoral Castle in 1863. He loved Britain, Kaiser Frederick III. He wanted Germany to imitate Britain in lots of ways. And because they were actually related to the British royal family quite closely. Queen Victoria was actually Kaiser Wilhelm's grandmother, because his mother was Victoria Princess Royal, who had married Frederick III. So you can see why he had such a close connection with Britain. So this is Emperor Wilhelm I, they call him Wilhelm the Great, who was responsible for appointing Bismarck, who unified Germany. As you can see here, this is the painting of the proclamation of the German Empire in 1871 after the Franco-Prussian War in the Hall of Mirrors at Versailles. Bismarck is the one right here in the white uniform. I think Frederick is somewhere in this picture. I think he's the one standing next to Kaiser Wilhelm right here. But anyway, and this is Bismarck, the Chancellor of Germany, responsible for unification, but also supported by Rudolf Virchow in his aggressive domestic policy, which targeted Polish people as well as Catholics, and obviously Polish people are mostly Catholic, so there's a bit of an overlap there. They were really not well treated in Prussia at that time. And here's a political cartoon mocking Bismarck's versatility. You know, he had lots of different offices throughout his career, so they have this drawing of him with his different outfits that he liked to wear, including the uniform of a general of the cuirassiers, which he was not a general at all, actually. His only military service was that of a reservist, but when he got put into the government, he was given the privilege to wear a cuirassier general's uniform. So he's kind of also mocked for that. And then this is Kaiser Wilhelm, who you might know from World War I, who replaced Frederick III at his death. Anyway, moving on, going further east to Austria and Bohemia, we have Karl Freiherr von Rokitansky, who was a Czech. He was of mixed German and Czech heritage. He was born in 1804 in Hradec Králové or Königgrätz. And his father was a civil servant named Prokop, and his mother's name was Teresia. So his father died young also, just like René Laennec's father, when he was young in 1812, and he was mostly raised by his mother. And she cared a great deal about his education, and sent him to Charles University, which is in Prague, and the University of Vienna, which he was appointed as the rector of the University of Vienna from 1852 to 1853. He identified such diseases as agenesis of the uterus, or somebody who was born without a uterus, the difficulty of evacuating blood from the liver, and ovarian cysts. So lots of different diseases. He performed 2 autopsies a week for 45 years, conducting over 30,000 autopsies in his lifetime. That was really his main practice, was autopsies. He was a doctor who began to challenge the traditional humors-based pathology of disease, and instead tried to replace them with more scientifically accurate anatomical factors. He conducted the autopsy of Ludwig van Beethoven, who lived from 1770 to 1827, and he determined that the cause of Beethoven's encroaching deafness was a malfunction of the inner ear, but was not able to discern more than that because of, well, it was the 1820s, what were you going to do, right? He demanded that the lunatics of Vienna be given access to a proper diagnosis of their mental disorders and be given more humane treatment. So if you've ever watched the movie Amadeus, do you remember the insane asylum they went to in that movie where people are just chained down and flailing about all over the place? Basically, that was the state of mental hospitals in Vienna at that point. He said, well, what if we tried to actually treat people with mental disease instead of just chaining them down? Anyway, in 1867, he was also, like many of the other doctors here, promoted to the nobility and given a permanent seat in the Austrian House of Lords. Not a bad idea, somebody smart like a doctor, maybe instead of all those lying politicians, He lends his last name to the main character, Max Rokitansky, in the 1979 movie Mad Max, because George Miller was a doctor before entering the movie business. True story. Yeah, good movie, I like that movie. But anyway, he also was awarded multiple orders of knighthood from many different countries. He was given the Imperial Austrian Order of Franz Joseph, the Royal Greek Order of the Redeemer, the Imperial Austrian Grand Medal for Science and Arts, the Commander's Cross of the Imperial Royal Austrian Order of Leopold, Commander's Cross of the Imperial Russian Order of St. Stanislaus, Officer's Cross of the Royal Greek Order of the Redeemer, again, so he had the Knight's Cross and Officer's Cross, Grand Cross of the Mexican Imperial Order of Guadalupe, and Officer of the Crown of Italy. So, yeah, he was a knight 4 or 5 times over, as well as being a baron. And he wasn't even born to nobility. You see, that's one of the great fallacies that people believe about nobility, is that people don't get promoted to it. But back in the day, you know, it wasn't necessarily untrue. And also, what about women doctors? Because the 19th century saw the very first female medical doctor, none other than Elizabeth Blackwell, who was born in 1821 in Bristol, England. And she initially worked as a school teacher, but she hated it. She absolutely despised her students. They were misbehaving rascals. So she became inspired to become a doctor when a friend of hers fell ill, and she told Elizabeth that she would have been preferred to be treated by a female doctor. So she applied to medical schools in England, but was rejected on the basis of her sex.
Mhm.
She applied to Geneva Medical College in New York and was accepted as a joke. They didn't think that she would actually cross the Atlantic to come to school there, but she did in 1847. She wrote her inaugural thesis on typhoid fever, which was published in 1849 in the Buffalo Medical Journal. She worked alongside her sister Emily, who became the second ever female medical doctor. They both worked as doctors in the American Civil War. Nasty business. She returned to England in 1874 to found the London School of Medicine for Women, which became the first females-only medical doctor school. She adopted an Irish orphan girl named Catherine Barry, who worked as her assistant. And she knew such illustrious, famous ladies as Elizabeth Cady Stanton, Lady Byron, and Florence Nightingale, who we will also talk about. So a very, very well-lived, famous lady here. And this is her and Catherine Barry. I believe she is the one here on the left with dogs. She was fond of animals. And Florence Nightingale. So what about her? Well, you might have heard of her. She's very famous. She was born in 1820 in Florence, Grand Duchy of Tuscany. That's why she was named Florence. She was born in Florence. To British expats, William Edward and Frances Nightingale. Her parents took her around Europe in her youth, visiting many countries. But in 1850, her most important stop was in Germany, where she was given medical training at a Lutheran religious community in Kaiserswerth am Rhein. She returned to Britain in 1853, where she served as a superintendent of an institute for the care of sick gentlewomen, which paid her £500 a month. So, not a bad gig. Very good money. She read about the appalling medical conditions of wounded soldiers in the ongoing Crimean War. Crimean War was pretty crazy. I'm not going to go into explaining why it happened, but suffice it to say, it was one of the major shakeups of the otherwise very peaceful 19th century in Europe. So she volunteered as a nurse in Constantinople, where she labored hard for wounded soldiers in the hospital of the Ottoman Empire. She introduced hand washing, remember? Not exactly a very well-known practice back then, you know. It had only been invented about 10 years earlier. Well, not invented. People were washing their hands, but like not medically. Especially not with lime for disinfection. But anyway, she also introduced thorough sanitization to the otherwise festering hospitals. Yeah, you can imagine. I'm just going to leave to the imagination how horrible and fetid the hospitals must have been. So she reduced the death rate from 42 to only 2%. But 4,077 soldiers still died in the hospitals in her first year. So, still very tragic, but think of how many deaths she could have prevented if that was how many who died. So later in 1860, she set up a training school for nurses in England called the Nightingale Training School. She was the first recipient of the Royal Red Cross. She also received the Order of Merit and was created a Lady of Grace of the Order of St. John. She was also awarded an honorary Freedom of the City of London. She was famous for her heterodox religious views. She had all kinds of strange, nonconformist religious ideas. And she died in 1910 at the age of 90. Her family declined the offer of burial at Westminster Abbey. Wow, right? Think about, hey, would you like to your daughter be buried? Not daughter, I think it was, I don't know which next of kin was offered this, but they declined it. I don't know why, but they chose instead a humble, relatively humble, compared to Westminster Abbey, grave at a churchyard at St. Margaret's Church in East Vellow, Hampshire. And this is a painting made of her treating soldiers in the Crimean War, you know, very saintly, angelic sort of figure here. This is her with her nursing students. She is the elderly lady in the middle right here. You know, hundreds, thousands of nursing students went through her schools. It was really night and day compared to like before Florence Nightingale versus after, you know. And this is her relatively humble grave at that churchyard. You know, definitely not Westminster Abbey. I wouldn't reject Westminster Abbey, I'll just tell you. But to each their own. You know, you gotta leave spaces for other famous Britons. And what about all these newfangled X-rays? Well, yes. So Wilhelm Conrad Röntgen was a physicist, not a medical doctor, so we won't be talking about him specifically, but he discovered X-ray imaging in 1895 while performing experiments with these things called Crookes tubes, which emit radiation. And he saw his skeleton appear on a barium platinocyanide screen. I don't know what a barium platinocyanide screen is, but it's some kind of screen that glows when you shoot radiation at it. And he had seen that, and he's like, wait, I just saw my skeleton. This has like an interesting thing. So he made his wife take a picture of her hand, which is this rather blurry photograph right there. And she exclaimed, I have seen my death. She was very, very, you know, you'd be freaked out if you saw that, right? Especially if you had no idea what an X-ray was, didn't understand anything about it, it would have seemed like sorcery. The picture, you know, has been preserved for us. This other photograph here is a picture of one of his lab assistants' hands, a little bit clearer, which is often confused for that other photograph there. Anyway, the first clinical use of X-rays was later in 1896 in the U.S. by doctors Gilman and Edwin Frost to examine the fractured wrist of a 12-year-old boy named Eddie McCarthy. However, this photograph, or these X-rays, have not survived to us, which is very sad. Pity. However, Emil von Behring, the savior of children, no small exaggeration. So he was born in 1854 in Hansdorf, East Prussia, and was the son of the local schoolmaster. His family had 13 children, just like another doctor. So, you know, doctors coming from large families, you wouldn't have thunked it, but here we are. So between 1874 and 1878, he studied medicine at the Kaiser Wilhelm Academy in Berlin, which was a military doctor's school, focusing on the prevention of infection in surgery, which you can see might have a military application to it. You know, because after the American Civil War, medical reports from American doctors circulating around the world had been informing people of the danger of infection from surgery. You know, because if you're getting an arm cut off, there's a very high chance you're going to die of infection. In fact, when I was in Georgia, I believe it was in Georgia, we visited a plantation house where the upper floor had been used as a hospital during a battle. No, it wasn't in Georgia, it was in Tennessee. Anyway, not important, in the South. This plantation house, and they basically said, oh yeah, most of the men who went in here died, not necessarily of their wounds, but from infection.
Wow.
So, in the American Civil War, infection was a huge killer. So basically, all the military doctors of the civilized world had been set to work figuring out how to prevent infection, mostly by utilizing either proper sanitation or a carbolic steam spray from Dr. Lister. He became a military doctor and served as a doctor with a Hussar regiment, and he published a paper with the Japanese doctor Kitasato Shizaburo, who we will also discuss very soon, announcing that they had discovered the antitoxin to diphtheria in 1890. Huge breakthrough. Diphtheria, also huge killer of the 19th century. And they had achieved this by injecting animals with diphtheria, and if they survived and achieved immunity, they would take their blood and use it to create a serum of the antibodies. Trials began in 1892, and it was finally used in treatment in 94. And he received the 1901 Nobel Prize for his discovery and was also promoted to the nobility, again, like so many of these other illustrious doctors. He set up a factory to produce diphtheria antitoxin, and he died in Marburg, Hesse-Nassau in 1917. So there was a crater of the moon named after him, the Emil von Behring Memorial Lunar Crater, on the bright side of the moon, not on the dark side. Can't see the dark side. Anyway, so another doctor we have here is Paul Ehrlich, who was born in 1854. And you might be wondering, well, why are so many of these doctors Germans? Well, don't you know, Germany was at the front of the world in terms of scientific discovery in the 19th century. They really valued scientific innovation and education. And most of their doctors, the ones that didn't go into general practice, went into research for developing new medicines. So he was born in 1854 in Strehlen, Silesia, as the second child of Rosa and Ismar Ehrlich, and his father was the leader of the local Jewish community. So he went to school in Breslau and attended the Charité Medical School in Berlin. He also traveled to Egypt, but this time for personal reasons, in 1888 to 1889 to cure a case of tuberculosis he had contracted while working in his lab. Because as you might be able to remember, the only way to get over tuberculosis in the 19th century is to travel to hotter climes, drier climes, and hope that the body will take care of it itself. Which, in his case, apparently, he got lucky and he did. It wasn't very likely that you would recover from tuberculosis with this treatment. But anyway, in 1891, he was invited to work for Robert Koch as a research assistant, which he invented the drug Salvarsan, which is the cure for syphilis. Huge breakthrough, this man. He was less successful, however, in his cancer research. He attempted to create a cancer vaccine by injecting people with cancer. Because he thought that cancer worked on the same principle as other drugs. I mean, not other drugs, other diseases. But unfortunately, injecting people with cancer cells either did nothing or gave them cancer. So, not a good idea. Although I think he tested it on humans. I think he tested it on animals, but still. It didn't really work out. But anyway, he theorized a magic bullet treatment for a disease where a theoretical drug would kill only the microbes responsible for a certain disease. Now, treatments like this have been achieved with varying degrees of success, usually involving antibodies. And he died in 1915 and was eulogized by the Kaiser himself. Kaiser Wilhelm II had this to say: "I, along with the entire civilized world, mourn the death of this meritorious researcher for his great service to medical science and the suffering of humanity. His life's work ensures undying fame and the gratitude of both his contemporaries and posterity." He was buried at the Jewish Cemetery of Frankfurt. So one of the most unsung, well, not unsung in his day, but forgotten nowadays, certainly, doctors of the world. And here is his grave at Hamburg's Jewish Cemetery. So, what about this Kitasato Shiba Saburo guy? So, Baron Kitasato Shiba Saburo was born, I know these names are kind of hard, right? No, it's all right. In 1853 at Okuni Village, Kiso Province, Tokugawa Shogunate. When he was born, Japan was still under the shogunate. And in fact, that same year that he was born, Commodore Perry had sailed to Japan and ordered them to open their ports. His father, Kitasato Korinobu, was headman of the village, and his mother, Tae, was the daughter of a samurai. So, impressive pedigree. His parents were serious about his education, as so many are in Japan, and sent him to live with relatives. His leadership qualities were said to be inherited from his mother, which does not surprise me at all. She was the sire of a samurai. And he attended Kumamoto Medical School and Tokyo University. He went to Germany. Many Japanese doctors went to Germany. There was an exchange program set up where Japanese doctors would go to the West and bring the learning home. Part of the modernization drive of the Meiji Restoration. And he worked under Robert Koch at the University of Berlin from 1885 to 1891. In 1889, he was the first to isolate the tetanus bacteria, and in 1890 developed a serum cure for tetanus alongside Emil von Behring, as well as cures for diphtheria and anthrax.
Wow.
So, you know, he's a very important doctor, not very well remembered outside of Japan, however. He demonstrated that dead bacteria could be used for vaccination, which is where basically all vaccines these days come from, is from dead bacteria. He went to Hong Kong in 1909 during a plague outbreak to discover the bacteria responsible for plague, which is called Yersinia pestis. He also studied a pneumatic variant of the plague, which appeared in Manchuria in 1911. He served as Dean of Medicine at Keio University, as President of the Japan Medical Association, and when he was elevated to nobility in 1924, served in the House of Peers of Japan in 1924. So, you know, very smart decision taking these bright doctors and elevating them to nobility and giving them a permanent seat in the upper house. You know, maybe we ought to try it. Anyway, he died of an intracranial hemorrhage in 1931. He was buried at Aoyama Cemetery in Tokyo. And he, as of 2024, is immortalized on the 1,000 yen banknote of Japan.
Wow.
So he's definitely well remembered in Japan, but unfortunately not very well in the West, despite providing so much to science. So what we can surmise from all these 19th century innovative doctors is that really we owe a great debt to them, so many of us, you know. People would not have lived nearly so long if it wasn't for all these innovations, no matter how small, you know, from just washing their hands and not drinking poop water to figuring out how to cure diphtheria and vaccinate people. So, you know, gotta give a hand to them, you know.
Yeah.
All right, that's it. That's our lecture.
Oh, right.
Thank you, everybody. Any questions? Any questions? Yes.
This isn't a question, but at Christmas, I went down to LA to stay with my granddaughter, and she had a fellow over who was from Germany.
Oh, yeah?
And he's a postdoc working at UCLA,
Wowzer.
and he's putting tiny little microscopes on mice to investigate their brains. And so I met the guy.
Wow.
On the news.
Really?
Yeah.
I didn't know
Robert
that.
Koch.
It was on the news.
Wow.
Well, you know, I wish him success in his research.
I mean, this is the cutting edge right now.
Yeah. You know, back, 100 and however many years ago, these people were in exactly the same spot. You know,
Right.
most of these people were chairs of this, chairs of that at universities. At least as their day job when they weren't, most of them were research doctors, not general practitioners.
I think someone asked what a Crookes tube was used
Oh,
for. They're,
somebody asked about that. Well, a Crookes tube, I'm not a physicist, but basically it's this glass tube with, I believe it has an electrode inside and it has a metal plate in the front,
yeah,
and because the air is evacuated from the tube, you get electrical current in the electrode, and the electrons from this electrode go to the metal plate, and it emits radiation from the metal plate.
they're early cathode ray.
Yeah, your televisions,
Your TVs have 3 cathode
not
rays.
these
Three
TVs, not these
primary.
flat ones, but back in the day, in the good old days of the tube television, you see a tube television works on the principle of the electrons being shot out of the cathode ray tube being manipulated by magnets, the magnetic deflection yoke, and it hits the screen. The screen of the television has this phosphor chemical on it, and basically the electron beam is manipulated to go in a raking line pattern.
So prior to those, these cathodes, these Crookes tubes were how they made yellow light.
So
And he happened to, they were experimenting with yellow light for precursor to what became a TV when he discovered this X-ray phenomenon.
yes, but you see, his Crookes tube was modified in some way, I don't remember, to not just produce electrons, but I guess I'm not a physicist, so I wouldn't know, but he did something to the tube to make it produce, which at that point were unknown wavelengths of radiation, which became X-rays, because X stands for unknown in mathematics. So he,
Oh, yeah.
because X-rays were unknown to them at that time, so he called these new rays X.
What he actually ended up doing is
Hence
it blocked the yellow color and you so you could see where the bone was blocked more than the other areas. That's what I looked at.
And in many European languages, not ours, sadly, a X-ray is called a Rontgenogram. So they call them that, so they remember Dr. Rontgen for inventing.
Isn't that Röntgen?
Röntgen. Sorry,
I always heard Röntgen.
my brain is on Anglo mode, isn't it? Anyway, so any other questions?
And Happy New Year.
Yes, happy. I'm sorry, I should have said that when I was coming in. We're in 2026 now.
Yeah.
Right,
But anyway, thank you everybody for
Thank
being
you.
here.
Thank you. That was interesting, yeah.
So these